Hello, I'm Anna Mackay and this video is on linear relationships in the topic of functions and graphs. So a refresher here, where do we place the independent and dependent variables? Do you remember which is which? So we have the dependent on the vertical axis and the independent on the horizontal axis. Often the x for the horizontal and y for the vertical, but that may depend on, we might be dealing with time or something like that. So how would you complete this sentence? The what variable depends on the what variable. So we have the dependent variable depends on the independent variable. So perhaps think something like water going into a water tank and time is elapsing. So how much water goes in will depend on how much time has elapsed. So the independent variable there would be time, and the dependent variable would be water. So as one example. Okay, so two variables are linearly related if the graph connecting them is a straight line. So I often like to think about the word linear has the word line in it. So that's a way of remembering that we're dealing with straight lines here. So having a think about these, which of the following are linear relationships? You have a think out of 1, 2, 3 and 4. So 1, 2 and 4 are straight line graphs. It doesn't matter if they're ascending or descending, that's fine, but number 3 is not. Okay, so for my students, some of these examples you need to start writing. So the first bit was some information. Write some of these examples down now, please. So this does come from your textbook too. So a taxi driver charges an initial fee of $4 and then $2 for each kilometre travelled. So if we had to fill out that table of values, how would we fill it out? So thinking about this first one here, if we've travelled 0 kilometres, you still have to pay the taxi driver that initial $4. So you put a 4 in that box. And then $2 for each kilometre on top of that. So once you've travelled 1 kilometre, you have the $4 plus the 2, so we're up to $6. So if you complete your table as such. Now, next, having a think about what that would look like as a graph. So our initial value is the y-intercept there. And so that's $4 when we've travelled 0 kilometres. And they are in a straight line, so they are linearly related. Okay, so just a few points about those. The graph of C against D, we say, so C being the y-axis against D, is a straight line, so they are linearly related, as we said. Now, and the C-intercept is 4, and that's our initial fee. So initial is the word that we often use for the y-intercept, C-intercept in this case. Now the gradient is 2. So think back to how this question was calculated. Every kilometre that you travelled, it cost you an extra $2. So this, the gradient is often referred to as the rate of change, and it's changing by $2 each kilometre. And the equation of that line is we have our y-intercept here, our vertical axis intercept, so that's $4. Hence that plus 4 you'll always have regardless of how much you've travelled. And the 2 there, well, that is the gradient, the rate of change. So it's changing by $2 each time. And you'll remember that from the classic formula for a straight line, y equals mx plus c. Okay, concept of direct proportion. So here we have this y and that symbol, and x, and they mean that y is directly proportional to x. So it looks a bit like the infinity sign, but not quite complete. And that relates to these straight line graphs, but specifically, they must go through the origin to be directly proportional to each other. And the formula for that is y equals mx. Technically, we have a plus c, but it's plus 0 because it's going through the origin. That's also referred to then in these cases as the proportionality constant. It's also the gradient or the slope of the graph. So having a think, if x is doubled, trebled or halved, then y is going to be directly proportional to that and the changes that's going to happen there. Okay, so Now, copying down this example. Example 1, Belinda the baker uses 3 eggs in each cake she makes. Sorry if you can hear some construction work outside. Show that X, the number of cakes made, is directly proportional to Y, the total number of eggs used. So having a think about that, if she makes no cakes, how many eggs is she going to use? None. If she makes 1 cake, how many eggs? 3. So you would show that as a table of values, as we've got here. So here are the different number of cakes and here are the different number of eggs in the Y term. So how to show that? We can graph that and you can see that they are in a straight line to each other, and therefore we show that they're directly proportional. Next it asks us to find the proportionality constant. So remember, that's fancy words for the slope or the gradient or how much is changing each time. And it's the number of eggs, and it's changing by 3 eggs each time. Now, how do you do that? You may remember that from the y2 take y1 over x2 take x1. So you would take 2 coordinates. So if this here is our second coordinate, so we've got the y2 of 3, which is here, subtract the y1 of 0, and then x2 take x1, calculate that, and there is our 3. And that matches with what we expected to happen. And then finding the equation, as we know, it's from y equals mx plus c is 0 here, and we already know that, as discussed earlier, that the proportionality constant is the slope, so we put it in there for y equals 3x. Okay, so that's the end of this video. If you liked it, give it a thumbs up and subscribe to the channel. And the next video in the series is called, I've forgotten. It'll be written down the bottom of your screen right there. Thank you.